We're going to discuss various mathematical functions provided by the Java code libraries. These functions will be broken up into various categories. First one being trigonometric methods. In studying angles, we often use such trigonometric functions as sine, cosine, tangent, and their inverses. Java provides these, but uses angles measured in radians, not degrees. If a problem is using degrees, those degrees must be converted to radians before using the trigonometric functions. To avoid the need for memorizing or frequently typing in the value of pi, the constant math.pi in uppercase is available for use. Another section is exponential methods. Java provides a power function since it does not have an exponentiation operator. The square root method is provided for readability. One could use the power function with an exponent of 1/2 to obtain the square root, but it's much more readable if the square root method is used. Both base 10 and natural logarithms are provided in the Java libraries. Be sure to use the one that is correct for the logarithms you are working with. Various rounding methods are provided. I have discussed these in a previous section. A quick review might be in order. Truncation is a way of converting a floating point number to an integer by chopping off the decimal and all the fractional portion. The ceiling method returns the next integer in the direction of positive infinity. On a number line, you would mark the number and then move right to the next integer. That would be the result of the ceiling function. Floor is its converse. On the number line, picking the value of a floating point number and then moving towards negative infinity or towards the left to the next integer would be the result of the floor method. Two rounding methods are provided, round and rint. When a value to be rounded is exactly n, whatever the number is, 0.5, round by default returns the next higher integer. That default can be changed. Rint returns the nearest even integer. That behavior also can be modified. Here is a formula that can be used for a consistent and well understood rounding formula if the behavior of the others is not exactly what you want in all conditions. This always rounds to the next highest magnitude when the fractional portion is 0.5. A positive value will round up to the next higher integer. A negative value will round down to the next lowest integer. Various miscellaneous methods are provided to help with various mathematical issues. Min and max take two values and return either the minimum or the maximum value of those two. The abs method takes a value and returns the absolute value. For 0 or greater, that value will be returned. For any negative value, its positive magnitude will be returned. The random method has been discussed previously. In that discussion, I mentioned there was a formula that better expresses how to develop a range of random values. The more ideal formula is first plus the integer truncation of the quantity math.random times last. In rolling the six-sided die, we would say first is 1 and last is 6. The math.random times 6 would return a value in the range 0 to 5.99 continuing. Truncate that and we would get just the integer portion, which is 0 through 5. And when that's added to first, which is 1, we get 1 through 6. The actual value, first plus last, is not included in this range. My example of the die, that's fine. Sometimes it feels more right to have first plus last as the last value. If that's wanted, simply take last and add 1 to it prior to the multiplication. For example, if we wanted to simulate a test score in the range of 0 to 100, we would take first as 0, add to it the truncation of math.random times 100 plus 1, or 101. After the multiplication has occurred, we will have a value in the range 0 to 100.999 maximum. Truncation will give us a value in the range 0 to 100. Add that to first, which is 0, and we now have a range 0 to 100.